So hello everyone, in this video we are going to look at another very um, easy level concept uh, as far as bit manipulation is concerned, and the agenda of today's video is to get ith bit of any number. Is basically to get ith bit of any number. So before diving into the coding part, let's just understand the problem statement and the logic behind it. So today's goal is get ith bit, get ith bit, get ith bit. Perfect. Get ith bit. Now let's suppose the number is 12. So 12 can be represented as 1100. Okay. Now this is 0th position. This is first position. This is second position. And then this is third position. Perfect. Something like this. So if the value of I is 0, then we need to return 0. If the value of I is 1, then we need to return 0. If the value of I is 2, then we need to return 1. If the value of I is 3, then also we need to return 1. However, if someone asks you what is the value of bit for I is equal to 4, then by default these are zeros, nothing much. So this is fourth is 0 and so on. Okay. So so this is how a value of I will be given and a number will be given. Now based on the given number and the value of I, we need to find whether the for a given number at ith position the bit is set or not set, that is 1 or 0. Okay, so let's go with number 13. So 13 is basically 1101. Okay, 13 is basically 1101, and let's suppose value of I is 2. Value of I is 2. Okay, so in this case the concept is very simple and similar to bit mask. So what is will be bit mask in this case? Bit mask will be, don't worry if this is new for you, you will get used to this the more you practice this. So bit mask will be 1 left shift I times 1 left shift I. So in this case, when I is 2, bit mask will be 1 left shift 2, which is nothing but 0 1 0 0 0 1 0 0. Now we will do number n and bit mask. We will do number and bit mask. So number is 13. 13 is 1101, and we need to end this with bit mask. So 0 1 0 0. Okay, perfect. So 1 and 0 is 0. 1 and 1 is 1. 0 and 0 is 0. 1 and 0 is 0. Perfect. Cool. But let's suppose the number was 9 and the value of I was 2. Okay, so 9 is basically 1001 and I is 2. So 1001, and we need to AND this with 0 1 0 0. So 1 and 0 is 0, 0 and 0 is 0, 1 and 0 is 0, 1 and 0 is 0. Perfect. So these are the two examples we discussed. For 9, I is equal to 2, bit mask is this. For 13, I is equal to 2, bit mask is this. Now when the bit was set at I is equal to 2 position, for number 13, then the output was non-zero, and when the bit was not set for I is equal to 2 position in case of 9, so answer was 0. Okay, so for ith position, after we find the bit mask, and if we do the AND operation and the result of AND operation is 0, then in that particular case, the bit at ith position for a given number is not set, that is 0 if the answer is 0, and if the answer is non-zero, then the bit at ith position is set, that is 1. Okay, so I hope logic is quite clear. Don't worry if you are unable to code it, you can anyways refer this video. However, I would just like to tell you to code this on your own now and just give it a try. Okay, so basic framework I have created, actual logic I have not written yet. So scanner SC we have defined, then enter a number, we have taken number num from user input, then enter the value of I also we are taking from user, and ith bit is ch check bit function I am calling, in which num and I are the two parameters I have been passing. Perfect. So now what we will do is static int check bit, and in this two parameters int num and int I. Perfect. Now we will create a bit mask first. So I int bit mask is equal to 1 left shift I times, and then now what? Now we will do nothing but just do that or AND operation. So if num and bit mask is equal to 0, so in this case we will return 0, else if it is non-zero then we will return 1. Perfect. So as simple as that. Now if we try to run it, so let's say for number 12 and I is equal to 2, answer should be 1. Perfect. Correct. So for number 12 and value of I 2, answer should be 1. And then similarly for number 12 and I is equal to 1, answer should be 0. Perfect. So it was this simple, and all we needed to understood how to assume our bit mask and the required operation. So bit mask was 1 left shift I times, and then if we AND it with our number, and if it is the resultant of AND operation is 0, then return 0, else return 1. Perfect. So that's all as far as this video is concerned. Thank you for watching till end. If you think I have made any significant contribution to your logic building, please do consider subscribing, and I will see you in the next one. Thank you.